Friends, till now we have learned about the importance of chemistry, scientific notations, significant figures, and laws of chemical combination. Now let's explore more about atoms and molecules. We know that matter is made up of atoms. You all have an idea what atoms are. You have studied this in your previous classes. Now, on discovering that matter is made up of atoms, scientists' attention shifted towards identifying the mass of the atoms. So let's talk about the atomic mass. The atomic mass or the mass of an atom is actually very small because atoms are extremely small. Today, we have sophisticated techniques like mass spectrometry for determining the atomic masses fairly accurately. One atomic mass unit is defined as a mass exactly equal to 1/12 of the mass of one carbon-12 atom. And 1 AMU, it is equal to 1.66056 into 10 raised to the power of minus 24. Friends, you can see on the screen, we have converted the mass of an atom of an hydrogen given in grams into AMU. Let's see how we can convert it. We know that mass of one atom of hydrogen, it is equal to 1.6736 multiplied by 10 raised to the power of minus 24 gram. And we know that 1 AMU is equal to 1.66056 multiplied by 10 raised to the power of minus 24 gram. So we will divide the mass of an atom of hydrogen given in gram by this unit, and we will get 1.0078 AMU as mass of the hydrogen or 1.0080 AMU. At present, AMU has been replaced by U, which is known as unified mass. Friends, let us learn how to calculate average atomic mass. You all know how to calculate the average of numbers. You have learned this in your previous classes. Same we are going to apply here. You know, many naturally occurring elements exist as more than one isotope. When we take into account the existence of these isotopes and their relative abundance, means percent occurrence, the average atomic mass of that element can be calculated. For example, carbon has the following three isotopes with relative abundances and masses as shown against each of them on the screen. From the above data, the average atomic mass of carbon will come out to be 12.011 U. Note that in the periodic table of elements, the atomic masses mentioned for different elements actually represent their average atomic masses. Now children, we will try to find out how to calculate molecular mass. Molecular mass is the sum of atomic masses of the elements present in a molecule. It is obtained by multiplying the atomic mass of each element by the number of atoms and adding them together. Let us see an example. Molecular mass of methane CH4, it is equal to 12.011 U, which is the atomic mass of carbon, plus 4 multiplied by 1.008 U, which is the atomic mass of hydrogen. It will come out 16.043 U. It is the molecular mass of methane. Friends, now try to find out what is the molecular mass of water. Now let us learn what is formula mass. Some substances such as sodium chloride do not contain discrete molecules as their constituent units. In such compounds, positive, which is sodium ion, and negative, which is chloride ion, entities are arranged in a three-dimensional structure, which you can see on the screen. In sodium chloride, one sodium ion is surrounded by 6 chloride ion, and one chloride ion is surrounded by 6 sodium ion. The formula, such as sodium chloride, is used to calculate the formula mass instead of molecular mass, as in the solid state, sodium chloride does not exist as a single entity. Now friends, try to find out the molecular mass of the following compounds. First, carbon dioxide. Second, ethane. Third, sodium carbonate. And you will also try to find out the formula mass of the sodium chloride. Friends, till now we have learned how to calculate atomic mass, average atomic mass, molecular mass and formula mass. If I ask you, how many atoms are there in 1 dozen? Or how many atoms are there in 1 score? Then you will answer me that there are 12 items in 1 dozen, 20 items in 1 score. Similarly, 144 items are present in 1 gross. Now we will use this idea of mole to count entities at the microscopic level. Atoms and molecules are extremely small in size, and their numbers in even a small amount of any substance is really very large. To handle such large numbers, a unit of convenient magnitude is required. For this, we use the SI unit mole to determine the amount of substance. 1 mole is the amount of a substance that contains as many as particles or entities as there are atoms in exactly 12 gram of the carbon-12 isotope. 1 mole of carbon weighs 12 gram. The number of atoms in it is equal to, as you can see on the screen, 12 gram per mole of carbon-12 upon 1.99268 multiplied by 10 raised to the power of 23 gram per carbon atom. Now we will get it is equal to 6.0221367 multiplied by 10 raised to the power of 23 atoms per mole. This number is known as Avogadro's number or Avogadro constant. It is denoted by capital N, and in subscript we will write A in the honor of Amedeo Avogadro. 1 mole of hydrogen atoms, it is equal to 6.022 into 10 raised to the power of 23 atoms. Or we can say 1 mole of water molecules, it is equal to 6.022 into 10 raised to the power of 23 water molecules. In the same manner, 1 mole of sodium chloride is equal to 6.022 into 10 raised to the power of 23 formula units of sodium chloride. The mass of 1 mole of a substance in grams is called its molar mass. The molar mass in grams is numerically equal to atomic, molecular, formula mass in U. Thus, we can conclude that the mass of 1 mole of the substance is equal to its molecular mass. For example, molar mass of water, it is equal to 18.02 gram per mole, and molar mass of sodium chloride, it is equal to 58.5 gram per mole. Now friends, task for the day. Try to calculate the molar mass of sulfuric acid and sodium hydroxide. And as you can see on the screen, there is one numerical also. Calculate the number of atoms in each of the following. A. 52 moles of argon. B. 52 U of helium. C. 52 gram of helium. Now, you will be able to find out the atomic mass, molecular mass, formula mass, and you will be able to explain the mole concept and molar mass also. Friends, so far we were dealing with the number of entities present in a given sample. But many a time, information regarding the percentage of a particular element present in a compound is required. Suppose an unknown or a new compound is given to you. The first question you would ask is, what is its formula, or what are its constituents, and in what ratio are they present in the given compound? Let us understand it by taking the example of water. Since water contains hydrogen and oxygen, the percentage composition of both of these elements can be calculated as follows. Mass percent of an element is equal to mass of that element in the compound divided by molar mass of the compound into 100. Now please look to the screen. Molar mass of the water is 18.02 gram. Now we have to calculate the mass percentage of the hydrogen. First we will write the mass of the hydrogen in the given compound upon total mass of the compound into 100. So here the mass of the hydrogen is 2 into 1.008 divided by 18.02 into 100. It will be equal to 11.18. Now mass percentage of the oxygen. Here we will write the mass of the oxygen in the given compound, that is 16, divided by molar mass of the compound, that is 18.02 multiplied by 100. It will come 88.79. Now let us take one more example. What is the percentage of carbon, hydrogen and oxygen in ethanol? First, we will calculate the molar mass of the ethanol. We know that molecular formula of the ethanol is C2H5OH. Molar mass of the ethanol is 2 into 12.01 plus 6 into 1.008 plus 16 gram. It is equal to 46.068 gram. Now for calculating the mass percent of carbon, first we will write the mass of the carbon upon total mass of the compound multiplied by 100 and you will get the answer 52.14%. In the same manner, we will calculate the mass percent of hydrogen. Mass of the hydrogen upon total mass multiplied by 100 and we will get 13.13%. In the same manner, we will calculate the mass percent of oxygen. It is mass of the oxygen upon total mass into 100 and it is equal to 34.73%. Now children, task of the day. You have to calculate the percentage composition of calcium carbonate and acetic acid. Friends, the molar mass and the percentage composition helps us to understand the quantitative data associated with a chemical compound. But how does one arrive at the chemical formula of a chemical compound? In other words, how did the scientists obtain the chemical formula H2O? Let us find out the answer of this. The chemical formula of compound is derived from two parts, empirical formula and molecular formula. An empirical formula represents the simplest whole number ratio of various atoms present in a compound, whereas the molecular formula shows the exact number of different types of atoms present in a molecule of a compound. Now we will study how to find out the empirical formula and molecular formula. Let us take an example. A compound contains 4.07% hydrogen, 24.27% carbon and 71.65% chlorine. Its molar mass is 98.96 gram. What are its empirical and chemical formulas? Now we will study the steps to find out the same. Step 1. Conversion of mass percent to grams. Since we are having the mass percent, it is convenient to use 100 gram of the compound as the starting material. Thus, in the 100 gram sample of the above compound, 4.07 gram hydrogen, 24.27 gram carbon and 71.65 gram chlorine are present. In the second step, we will convert it into number of moles of each element. Divide the masses obtained by respective atomic masses of various elements. This gives the number of moles of constituent elements in the compound. Now, we will calculate the number of moles of hydrogen, carbon and chlorine. Moles of hydrogen is equal to 4.07 gram divided by 1.008 gram. It will come 4.04. Number of moles of carbon, it is equal to 24.27 gram divided by 12.01 gram. It is 2.021. Now number of moles of chlorine, it is equal to 71.65 gram divided by 35.453 gram. It is equal to 2.021. Now in the step 3, we will divide each of the mole values obtained above by the smallest number amongst them. Since 2.021 is the smallest value, division by it gives a ratio of 2:1:1 for hydrogen is to carbon is to chlorine. In case the ratios are not whole numbers, then they may be converted into whole number by multiplying by the suitable coefficient. Now in the step 4, we will write down the empirical formula by mentioning the numbers after writing the symbols of respective elements. CH2Cl is the empirical formula of the above compound. Now children, we will write the molecular formula. First, we will determine empirical formula mass by adding the atomic masses of various atoms present in the empirical formula. For CH2Cl, empirical formula mass is 12.01 plus 2 multiplied by 1.008 plus 35.453. It is equal to 49.48 gram. Now we will divide molar mass by empirical formula mass. It is equal to 98.96 gram divided by 49.48 gram. It will come 2. It is the value of N. Now in the next step, we will multiply empirical formula by N obtained above to get the molecular formula. Empirical formula, it is equal to CH2Cl. Here N is 2. So to get molecular formula, we will multiply this 2 to CH2Cl. We will get C2H4Cl2. Friends, now task of the day. Try to determine the empirical formula of an oxide of iron which has 69.9% iron and 30.1% dioxygen by mass. One more question you will try. A welding fuel gas contains carbon and hydrogen only. Burning a small sample of it in oxygen gives 3.38 gram carbon dioxide, 0.690 gram of water and no other products. A volume of 10 liter measured at STP of this welding gas is found to weigh 11.6 gram. Now you have to calculate empirical formula, molar mass of the gas and molecular formula. Children, here I want to tell you one thing. What are STP conditions? Standard temperature and pressure conditions. It means standard pressure you will take here 1 bar and standard temperature 0 degree Celsius. So in the upcoming chapters where you have to calculate the empirical formula or molecular formula or percentage composition, I think you will be confident. Friends, we have learnt about mole concept, molar mass and percentage composition. To measure the amount of reactants needed in a chemical reaction, we will study the concept of stoichiometry. The word stoichiometry is derived from two Greek words, stoichion meaning element and metron meaning measure. Stoichiometry thus deals with the calculation of masses, sometimes volumes also, of the reactants and the products involved in a chemical reaction. Before understanding how to calculate the amounts of reactants required or the products produced in a chemical reaction, let us study what information is available from the balanced chemical equation of a given reaction. Let us consider the combustion of methane. A balanced chemical equation for this reaction is CH4 plus 2O2 gives CO2 plus 2H2O. Here, all the reactants and products are in gaseous state, and this has been indicated by letter small g. Similarly, in case of solids and liquids, S and L are written respectively. The coefficient 2 for O2 and H2O are called stoichiometric coefficients. Similarly, the coefficient for CH4 and CO2 is 1 in each case. They represent the number of molecules and moles as well taking part in the chemical reaction or formed in the reaction. Thus, according to this chemical reaction, 1 mole of methane reacts with 2 moles of oxygen to give 1 mole of carbon dioxide and 2 moles of H2O, or 1 molecule of CH4 reacts with 2 molecules of O2 to give 1 molecule of carbon dioxide and 2 molecules of H2O. Or we can say 22.7 liter of methane reacts with 45.4 liter of oxygen to give 22.7 liter of carbon dioxide and 45.4 liter of water. In other words, we can also say 16 gram of methane reacts with 2 multiplied by 32 gram of oxygen to give 44 gram of carbon dioxide and 2 multiplied by 18 gram of H2O. From these relationships, we can convert mass into moles, moles into number of molecules, or number of molecules into moles and moles into mass and volume also. Dear children, we know that density is equal to mass per unit volume. So we can find out the density also by this. Now let us solve a numerical based on stoichiometric calculation. How many moles of methane are required to produce 22 gram of carbon dioxide after combustion? According to the chemical equation, CH4 plus 2O2 gives CO2 and 2H2O. Here, 44 gram of CO2 is obtained from 16 gram CH4. We know that 1 mole CO2 is obtained from 1 mole of CH4. So, number of moles of CO2, it is equal to 22 gram of CO2 multiplied by 1 mole of CO2 divided by 44 gram of carbon dioxide. We will get 0.5 mole of carbon dioxide. Hence, 0.5 mole CO2 would be obtained from 0.5 mole CH4, or we can say 0.5 mole of CH4 would be required to produce 22 gram of CO2. Now children, task of the day. Calculate the amount of water produced by the combustion of 16 gram of methane. Friends, let us consider a reaction in which one reactant is in more amount than the amount required by the balanced chemical reaction. The reactant which is present in the least amount gets consumed after some time. After that, the further reaction does not take place, whatever be the amount of the other reactant. Hence, the reactant which gets consumed first limits the amount of the product formed and is therefore called the limiting reagent. In performing stoichiometric calculations, this aspect is also to be kept in mind. Let us do an example. In a reaction, A reacts with B to form AB2. Identify the limiting reagent in the following reaction mixture. When 300 atoms of A react with 200 molecules of B. According to this reaction, 1 atom of A reacts with 1 molecule of B. So, 300 atoms of A will react with 300 molecules of B. That's why B is the limiting reagent here. Children, task for the day. You have to identify the limiting reagent for the following reaction. A plus B gives AB2, where the reaction mixture is 100 atoms of A react with 100 molecules of B, or 5 moles of A reacts with 2.5 moles of B. Now children, so far we have learned how to calculate the number of moles or molar mass or molecular mass in the given reaction of the various compounds. Now you will be able to perform various stoichiometric calculation. You will be able to identify the limiting reagent in a reaction. Now children, try to solve the problems given in your book, discuss with your friends, and still if you are having problem, ask your teacher and make your concept clear. Thank you. Happy learning.